Good morning or welcome grade 8 students. How are you? Good? Okay, so please go to www.cathomeschool.com and click for the curriculum. Alright, then enter the password. Good. Okay, then click for math because that will be our lesson for today, mathematics. Solving equations with unknown. So, our lesson is about repeating decimals. Are you ready? Okay, so let's start. So first, what is repeating decimals? Suppose we are building a bridge to go over a small creek. When we try to calculate how long the bridge needs to be, we end up with the decimal number 4.333. For each decimal place we calculate, we end up with the number 3 and recognize that this pattern will continue indefinitely. This number is called a repeating decimal. A repeating decimal is a decimal number that eventually takes on a repeating pattern of digits after its decimal points that will continue forever. We represent this by using 3 periods at the end of the number, like with the 4.3333 figure above. You can also indicate repeating digits by drawing a bar over them. For example, letter A 0.12535353. Letter B 1.75275272. Letter C 22.333333. Notice that for each of these numbers, the digits after the decimal point eventually take on a repeating pattern. For instance, in example A, we see the repeating pattern of digit is 53. In example B, the repeating pattern of digits is 752. While in example C, the repeating pattern of digit is just 3. No matter how many times we perform the calculation, these patterns will continue indefinitely. So, repeating decimals as fractions. When we return to our bridge calculation, we begin to wonder how we're supposed to measure pieces of wood to be equal to this length if the decimal just keeps going. All hope is not lost. How we're supposed to measure because the nice thing about repeating decimal is that even though they continue the repeating digit pattern forever, we can write them in nice compact form as fraction. This property holds true for all repeating decimals. We breathe a sigh of relief and decide that we will convert our 4.333 meters to a fraction since it's easier to measure a certain fraction of meter than it would be measured with a repeating decimal. So to convert a repeating decimal to a fraction, we perform the following steps. Step 1. Set up an equation by representing the repeating decimal with a variable. Using our example, we will let C represent the repeating decimal 4.3333. So we have C equals to 4.33333 as our equation. Step 2. Identify how many digits are in the repeating pattern or n digits. Multiply both sides of the equation from step 1 by 10th to the raised power n to create a new equation. Again, using our example, we see the repeating patterns consist of just one digit, 3. Now multiply both sides of the equation by the 10 to the raise of 1 equals to 10. Thus, we have 10c equals to 4 equals to 10 to the raised power of 4.333, or 10c equals to 43.3333. Step 3. Subtract the equation in step 1 from the equation in step 2. Notice that we subtract this equation, our repeating patterns drop off. Lastly, we now have an equation that we can solve for c and simplify as much as possible. Using c as a fraction, 9c is equal to 39 if we divide both sides by 9. We get c equals to 39 over 9. When simplified, we find that c equals to 13 over 3, or 4 and 1/3. Because 4.33333 equals to 13 over 3, or 4 over 1/3, we know that our bridge needs to be 4 over 1/3 meter long, which we can easily measure. Alright, so I have this video here because I know you don't really understand that by just reading, so let's all watch this.
Into fractions. So let's begin. Let's say if we have 0.1111 ... which is the same as 0.1 repeating. How can we convert this number into a fraction? 0.1 repeating is simply 1 divided by 9. That's it. So let's say if we have 0.2 repeating, or 0.222, where it goes on forever. 0.2 repeating is simply 2 over 9. Makes sense, right? You can type in your calculator 2 over 9, you'll see it's 0.22222. Now, what about this one? What is 0.3 repeating? 0.3 repeating is simply 3 divided by 9, which you can reduce it if you divide the top and the bottom by 3. So always check to see if you can reduce your answer. 3 divided by 3 is 1, 9 divided by 3 is 3. So 0.3 repeating is 1/3. Now what about this one, 0.5 repeating? 0.5 repeating is basically 5 over 9. 0.6 repeating is 6 over 9, but we can reduce it by dividing by 3 again. So 0.6 repeating is going to be 2 over 3. Now, instead of having one digit that repeats, what if we have 2 digits that repeat? For example, let's say if we have 0.232323, and it goes on forever, which is the same as 0.23 repeating. How can we convert this number into a fraction? So 0.23 repeating is simply 23 divided by 99. That's the answer. And can we reduce this fraction? It turns out that 23 is not divisible by 3, so we can't reduce it. Now what if we have 0.151515 repeating? Go ahead and convert that into a fraction. So this is the same as 0.15 repeating, or simply just 0.15 with the line on top. And that's going to be 15 divided by 9. Now 15 is divisible by 3, so let's divide the top and the bottom number by 3. 15 divided by 3 is 5. 99 divided by 3 is 33. So 0.15 repeating is 5 over 33 as an improper fraction, or just as a fraction in general. Now let's try this one. What is 0.36 repeating? Or 0.363636, and so forth. So this is going to be 36 divided by 99. And we could divide 36 and 99 by 3, but we can also divide it by a larger number, and that is 9. 36 divided by 9 is 4. 99 divided by 9 is 11. So the answer is 4 over 11. Now what if we have three numbers that repeat? So for example, let's say if we have 0.309, 309, 309, and so forth. So this is 0.309 with a line on top. To convert it to a fraction, it's going to be 309 divided by 999. So hopefully you see a pattern here. So now let's divide both numbers by 3. 3 divided by 3 is 1. So 300 divided by 3 is 100, and 9 divided by 3 is 3, so 309 divided by 3 is 103. 999 divided by 3 is 333. And it turns out that you can't really divide 103 by 3. If it was 102, it would work, but 103 doesn't work, so this is the answer. Let's try another example. What about 0.255, Go ahead and convert that into a fraction. Feel free to pause the video. So we can see that the repeating element is just 255, which is going to be 255 divided by 999. So let's see if it's divisible by 3. Let's divide 255 by 3. So how many times does 3 go into 25? 3 goes into 25 8 times. 8 times 3 is 24. And 25 minus 24 is 1. Let's bring down the 5. And 3 goes into 15 5 times. 3 times 5 is 15, so the remainder is 0. Therefore, 255 divided by 3 is 85. And if we divide 999 by 3, we're going to get 333. So this is the answer. Try this example. 0.369, 369, 369. So we can see that the repeating element is 0.369. Repeating. And so that's going to be 369 divided by 999. And then let's reduce it by 3 initially. So what is 369 divided by 3? 300 divided by 3 is 100. Well, you could just do 3 divided by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So 369 divided by 3 is 123. 999 divided by 3 is 333. It turns out that we can divide this again by 3. 12 divided by 3 is 4. And 3 divided by 3 is 1. Here's the 12th part. And 333 divided by 3 is just going to be 111, since 3 divided by 3 is 1. So the final answer for this example is 41 divided by 111. Now what about this one? 1.3333, or 1.3 repeated. How can we convert this into an improper fraction? So 1.333 is 1 plus 0.3 repeated. And 0.3 repeating, we know it's 3 over 9. And 3 over 9 reduces to 1 over 3. Now what you want to do is get common denominators. You want to multiply 1 over 1 by 3 over 3. So what you now have is 3 over 3 plus 1 over 3, which is equal to 4 over 3. So 4 over 3 is 1.333 repeating. Try this one. 2.55555. Feel free to pause the video. So we know this is 2.5 repeating. Now what you want to do is separate it into a whole number and decimal. So it's 2 plus 0.5 repeating. Now 2 is the same as 2 over 1. And 0.5 repeating, we know it's 5 over 9. So we need to get common denominators. Now let's multiply 2 over 1 by 9 over 9. So 2 times 9 is 18. So what we now have is 18 over 9 plus 5 over 9. And 18 plus 5 is 23. So if you have your calculator with you, if you type in 23 divided by 9, you're going to get 2.5555 repeating. So this is the answer. Let's convert this one into a fraction. 3.27 repeating. So this is going to be 3 plus 0.27 repeating, which is 3 over 1, and 0.27 repeated, we know it's 27 over 99. Now let's reduce 27 over 99. We can divide both numbers by 9. 27 divided by 9 is 3, and 99 divided by 9 is 11. So we have 3 over 1 plus 3 over 11. Now, to combine this into a single fraction, let's multiply 3 over 1 by 11 over 11. So 3 times 11 is 33. So then it's going to be 33 plus 3, which is 36 over 11. This is the final answer. Let's try another one like that. 4.57 repeating. So just like before, this is going to be 4 plus 0.57 repeating, which is 4 over 1 plus 57 divided by 99. So let's divide this number by 3. So what is 57 divided by 3? Well, let's use long division. 3 goes into 5 one time. 3 times 1 is 3, and 5 minus 3 is 2. So if you bring down to 7, 3 goes into 27 9 times. So 57 divided by 3 is 19. So what we now have is 4 over 1 plus 19 divided by 33. Now let's multiply 4 by 33, top and bottom. So what's 4 times 33? 4 times 30 is 120, since 4 times 3 is 12. And so when you think about it, 33 is 30 plus 3. And if you multiply this by 4, we said 4 times 30 is 120, and 4 times 3 is 12. If you add these two, you should get 132. Now let's add 19 over 33 to this. So what is 132 plus 19? 132 plus 19 is 151. So this is the final answer. It's 151 over 34, not 133. So that's it. Let's try this one, 4.156 repeating. So go ahead and see if you can work out that example. So this is going to be 4 plus 156 over 901. So let's begin by dividing this by 3. So what is 156 divided by 3? 156 is 150 plus 6. And let's divide each number separately by 3. If 15 divided by 3 is 5, 150 divided by 3 is 50. And 6 divided by 3 is 2. So 156 divided by 3 is 52. So this is going to be 52 divided by 333. Now we can't divide 52 by 4. It doesn't go into it. So all we could do at this point is multiply 4 by 333. So 333 times 4, that's 1332. And if we add 52 to it, you should get 1384 divided by 333. So that's the final answer. Consider this one, 0.583333. So if you get a decimal that looks like that, what should you do? So whenever you have multiple numbers, you need to identify the repeating element. The repeating element is 0.3. So what you want to do is find out what number is added to the repeating element. So what is x? 0.33333 plus 1 is equal to 0.58333. So in your calculator, or you can do this by hand, type in 0.5833333 minus 0.33333. So take this number and subtract it by the repeating element, and you will get 0.25. So now we can turn it into a fraction. 0.3 repeating, we know it's 3 over 9, which is 1 over 3. Now how can we convert 0.25 into a fraction? 0.25 over 1, what you need to do, multiply the top and bottom by 100. 0.25 times 100 is 25, and 1 times 100 is 100. So we have 25 over 100. Now, we need to reduce 25 over 100. And we could do that by dividing the top and the bottom part of the fraction by 25, which is going to be 1 over 4. So 0.25 is simply 1/4. Now, let's combine the two fractions into a single fraction. So let's multiply 1 over 4 by 3 over 3 to get a common denominator of 12. And for 1 over 3, let's multiply by 4 over 4. So this is going to be 4 over 12 plus 3 over 12, which I wrote 7 for some reason, but 4 plus 3 is 7. So the final answer is 7 over 12, and we could check it with a calculator. If you type in 7 divided by 12, you do get 0.5833333 repeating. So let's try another example like that. Try this one. 0.9155555. So the 5 is the repeating element. So this is going to be 0.5 repeating plus some other number. To find that other number, let's type in 0.9155555 minus 0.55555. And you should get about 0.36. So 0.5 repeated, and we know it's 5 over 9. 0.36, if you multiply it by 100 over 100, it's going to be 36 over 100, which we can reduce that if we divide by 4. 36 divided by 4 is 9, and 100 divided by 4 is 25. Now let's add the two fractions. Another way you can add two fractions is you can multiply 5 times 25, which is 125, that's 5/4, a buck 25, and 9 times 9, which is 81, and then multiply 9 times 25. So if you have 9/4, what is the value of that? 9/4 is 225. So 9 times 25 is 225. And then 125 plus 81. 120 plus 80 is 200. 5 plus 1 is 6. So this is going to be 206 divided by 225. So that's the answer. And let's just double check it with the calculator. And you do indeed get 0.915 repeating. Here's another example. 0.7224242424. Now, how would you convert that into a fraction? So we need to identify the repeating element. Is the repeating element 0.242424, or is it 0.424242? So here's what we need to do. Let's subtract it by 0.424242 first. Now this is how we're going to know if it's correct. If we subtract it by this number, and if we get an answer that repeats, then this is not the correct repeating number. If we get an answer that does not repeat, then it's correct. So if you type in 0.7224, 242424 and subtract it by 0.42, 424242, you're going to get 0.2981818 and so forth. So there's a repeating element in that answer. Now let's subtract it by 0.24242424. So 0.7224242424 minus 0.24242424. This will give you 0.48. And there's a lot of zeros after this number. So therefore, 0.24 is the repeating element. So what we have is 0.7224, that's the repeating part. This is equal to 0.48 plus 0.24 repeating. So now let's convert this into a fraction. So 0.48 is really 48 over 100. And 0.24 repeating is 24 over 99. So we can reduce 48. We can divide that by 4. Perhaps I should write it this way. And 24 over 99, we can divide that by 3. So 48 divided by 4 is 12. 100 divided by 4 is 25. 24 divided by 3 is 8. 99 over 3 is 33. So now this is going to be 12 times 33, which is 396, plus 8 times 25, 8 quarters is 200, divided by 25 times 33, which is 825. So 396 plus 200 is 596. So the final answer is 596 divided by 825. And you can type that in your calculator, divide those two numbers to see if you get the right answer. And you do indeed get 0.72242424. So now you know how to convert a repeating decimal into a fraction. Thanks for watching.
Okay, so
What? Still?
let's stop here for now, because on the next lesson I will be giving you examples and activities for our lesson for today. So please study repeating decimals, study the examples. Okay, grade 8. Okay, see you.